Okay, the next molecule that we had was NO2 minus, is ion, polyatomic ion. This one also had the resonance structure. You have oxygen, nitrogen, double bond with oxygen. The position of the double bond change. So it can be O, double bond, NO. Okay, I pick one of these for determining the domain. You have 2 bonds and 1 lone pair, so the domain is 2 plus 1, which is 3. So the hybridization is sp2. Electronic geometry for sp2 is trigonal planar. Molecular geometry would be bent as we had here. So for trigonal planar, as we said, it's like the Mercedes-Benz logo. Okay, one of them is the double bond with oxygen, one of them is single bond with the oxygen, and the domain which is at the top is just the lone pair. So I delete the bond, I put the lone pair here, and the angle from 120 decreases to around 170 degrees. The next molecule is ONCl. ONCl. The Lewis structure for that we have drawn in the class is O, double bond N, single bond Cl. Okay, so the number of the domain 1, 2, 3. We have 3 domains, 2 bonds, 1 lone pair. Hybridization is sp2, exactly the same as the molecules that we have above. Electronic geometry is trigonal planar. Molecular geometry is bent or V-shaped. And you have N, one domain with Cl, one domain is double bond with oxygen. You have one domain here which is lone pair there. Okay, and the angle again from 120 decreases to around 117. Okay, we had more molecules that we have drawn the Lewis structure for that as a homework. They are SiCl4, SCl2, Pi3, NH2Cl, and Cl2O. Okay, I ask you to pause this video and go and draw the Lewis structure for these molecules, then determine the domain of each one of them, the electronic geometry, the molecular geometry, and the bond angle. After you have drawn all of that on the paper or inside your notebook, let's come back to this video and check if you had got the correct structures and shape of the molecule for each one of them. Okay, so let's draw them here. I hope that you have drawn it on your paper and you can check your answer with me here. So the first one, SiCl4, the Lewis structure for that is SiCl, Cl, Cl, Cl. This was the Lewis structure for that one. The number of the domain for this molecule, 1, 2, 3, 4 bonds, no lone pair, so 4 plus 0, the domain is 4, so the hybridization is sp3. Electronic geometry, same as molecular geometry, they are tetrahedral. And for the tetrahedral structure, we draw the central atom here, one domain at the top, one domain to the right side, one domain is coming out of the screen, one domain is going into the screen or into the paper that you have drawn in your notebook. Okay, and there are Cl, 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 Cl. If you want, you can put the lone pairs here. And the angle would be 109.5 degrees. Okay, the next molecule, SCl2. So you have SCl2. The Lewis structure was like this. You have S, Cl, Cl. Okay, these are SCl2. Let's find the domain for that. We have 1, 2, 3, 4 domains around that one. 2 bonds plus 2 lone pairs becomes 4. So the hybridization is sp3. Electronic geometry would be tetrahedral, and molecular geometry is linear or V shape. Sorry, the molecular geometry is bent or V shaped. So let's draw the molecule. So you have central atom, one domain, 2, 3, 4. So this domain I put single bond with chlorine. This domain I put single bond with the chlorine, and these 2 domains I delete them and I put the lone pairs. So the molecule becomes bent or V-shape. The angle from 109.5 decreases to around 105 degrees. Okay, you can also put the lone pair for these ones. Okay, the next molecule is Pi3. The Lewis structure. This is the Lewis structure for Pi3. So how many domain do we have here? 1, 2, 3, 4 domains, 3 bonds plus 1 lone pair. Domain is 4. So hybridization would be sp3. Electronic geometry is tetrahedral. What about the molecular geometry? Okay, so let's draw the molecule first. So you have phosphorus, one domain here, one domain here, one domain is coming out of the board or screen, one domain is going inside the screen. Let's draw it better. So you have P, 1, 2, and these are the domains. So you have I, iodine. This domain that we have at the top is lone pair. So the shape of the molecule becomes trigonal, pyramidal. It's like the pyramid. Okay. The angle decreased from 109.5 to 107. You can put the lone pairs for this one if you like. Okay, the next molecule is NH2Cl. NH2Cl. The Lewis structure was like this. Okay, so how many domain do we have here? 1, 2, 3, 4. You have 3 bonds, 1 lone pair, so the domain is 4. Hybridization for that would be sp3. Electronic geometry for sp3 hybridization for 4 domain is tetrahedral. Okay, but the molecular geometry is different. It's trigonal, pyramidal. Okay, and if you want to draw it, it becomes N, 1 bond with hydrogen, 1 bond is coming out with the hydrogen, 1 bond is going into the screen with the chlorine, and you have 1 domain here which is lone pair. Okay, so there is no difference when you put the chlorine and hydrogens because all of these 3 positions are exactly the same, and the bond angle decreases from 109.5 to 107. Okay, so the last molecule that I hope you have drawn it is Cl2O. Its Lewis structure is like this. So you can see in all of these, it's very important to know the Lewis structures. So work on the Lewis structures very well. If you cannot draw the Lewis structures, then you cannot answer to the rest of the question in the exams. So the domains 1, 2, 3, 4. So the domain is 2 bonds on 2 lone pairs. So the domain is 4. So hybridization would be sp3. Electronic geometry tetrahedral, and molecular geometry, when in the tetrahedral structure you have 2 lone pairs, the molecular geometry would be bent or V-shaped. Okay, and you have, okay, so you can just simply draw the bent molecule Cl2 lone pair here. Okay, so this is the bent molecule, and the angle that you have here decreases to 105. Okay, let's draw the last 2 molecules in this part, and then we will finish this topic. Okay, the molecule PCl5, their Lewis structure was like this: PCl, Cl, 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 Cl. Okay, so this was the Lewis structure for PCl5. Let's find its domain around central atom. 1, 2, 3, 4, 5. So you have 5 domains around the central atom, 5 bonds, no lone pairs, so the domain becomes 5. When the domain is 5, the hybridization is sp3d. When the hybridization is sp3d and you don't have any lone pair, the molecular geometry is same as electronic geometry, and they are trigonal bipyramidal. The structure of the trigonal bipyramidal you can see here. This is the structure of trigonal pyramidal. Okay, so here at the center you have phosphorus, you have 1 bond on the screen with the chlorine, 1 bond at the bottom with the chlorine, 1 bond at the top with the chlorine. This bond is coming out of the board, so you have to draw it in bold format. This one is going into the screen, so you have to shade that one. This would be the shape of your molecule. So the electronic geometry and molecular geometry are same. Both of them are trigonal, pyramidal. So I will draw them here on this page that we were drawing them. So for drawing the trigonal bipyramidal structure, you draw the central atom, you have one domain at the top, one domain at the bottom, one domain at the right. All of these three domains are on the screen, and here you have one domain which is coming out of the screen and one domain which is go into the screen, and just put the atoms here. Okay, I put the lone pairs. So what was the angles that we had here? Between these domains on the central plane, the angle was 120 degrees. Between each of these domains at the top and the bottom with the domains on the central plane is 90 degrees. And between these two domains, which are opposite to each other at the top and the bottom, the angle is 180 degrees. Okay, so I showed the three-dimensional structure for that one here. You have 5 domains, 1 2 3 4 5. Okay, this is the structure. So you can see we have one domain at the top, one domain at the bottom. I can rotate the molecule. One domain at the bottom, one domain here on the right side. One domain is coming out, this domain, and this domain is going into the screen. So this domain, this one, and this one, they are on the screen. This one is coming out, this one is going out. So these three, when you want to draw these three, you draw them solid line. This one you draw it by the bold line, this one you draw it by the shaded one. Okay, let's go and draw the shape of the molecule for the last molecule that we have here, and then we will finish this topic. It's SF6. The Lewis structure for that one was like this. You have 6 single bond between sulfur and fullerene. This was the Lewis structure. So how many domains do we have here? 1 2 3 4 5 6. You have 6 domains. So the domain, you have 6 bonds, no lone pair, so the domain is 6. When the domain is 6, the hybridization is sp3d2, and the electronic geometry and molecular geometry, both of them are octahedral. Okay, so I want to show you the octahedral arrangement here. These are the octahedral arrangement. So okay, sorry for the problem that we had during the video. Okay, so this is the octahedral arrangement. Okay, so all of these domains are equal to each other, and the angle between all of them are 90 degrees. So you can rotate it in any ways. So this is how we draw it on the paper. Okay, so we have one domain here at the bottom, one domain here at the top. Okay, then this domain and this domain is coming out of the screen, and you have two domain at the back, this one and this one. So they are drawn in shaded line when you want to draw it on the piece of paper. So let's go back here. I will show you how we have to draw the shape for the octahedral. This is the octahedral molecule. At the center you have S. On the screen it has F. At the top you have F. These two, they are coming out of the screen. So when you want to draw it, you must draw it in the bold line, and these two are going in the back. So we draw them in the shaded format. This one and this one, F and F. Okay, so this is how we draw the octahedral structure, and the angle between all of them are 90 degrees. All 90 degrees. Even angle between these are 90 degrees. Between these two, the angle is 90 degrees. So all of the angles are 90 degrees. So let's go back to the other page and draw the octahedral arrangement for SF6 sulfur hexafluoride or molecule. So you have central atom, one domain at the top, one domain at the bottom. These two domains are coming out of the board. These two domains are going inside the board or a screen, and you have F, 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 fluorine, 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 fluorine. Here I don't show the lone pairs here, and the angle between all of them are 90 degrees. Okay, sorry for some problems at the end of this video, but this is all about the Lewis structures, valence shell electron pair repulsion theory, and how we can use this theory for predicting the shape of the molecule and for predicting the angle of this molecule. So knowing the shape of the molecule is very important to for identification the polarity of the molecule. The polarity of the molecule is a new concept that I will explain it to you in the next video.